Bismillahirrahmanirrahim. Iyyaka na'budu wa iyyaka nasta'in. Today we just towards our topic, that is water, and in which we are basically going towards the study of properties of water. Now, actually, what is basically the occurrence of water and how much amount that water is present in an environment? When you go for the oceans, it contributes about 97% of Earth's water, as well as when you go for the glaciers and ice caps, it's round about 2.1% of Earth's water. Groundwater almost contains about 0.6%. Atmospheric water contains 0.001%, and inland water contains 0.2% distribution of water on Earth. As far as the potable water is concerned, it is round about 0.2% of total water that is present on Earth. Potable water is that water which is basically there, or it is fit for drinking, because all water on Earth, it is not potable. Most of the water is unfit for drinking, and from that you can imagine that this is the total occurrence of water on Earth. Atomicity is actually related to the number of atoms which are present in one molecule of water. And when you go for the structure of water, it consists of two elements, oxygen and hydrogen. One atom of oxygen combines with the two hydrogen atoms in one molecule of water molecules. So you see that over here you are having that red part. That red part is basically oxygen, which is slightly bigger than that of the remaining two white balls. So this is basically hydrogen on both sides, and water basically having a bend structure with the angle of 104.5 due to the presence of two lone pairs on it. So this is the structure, level structure of water, where you are representing the two lone pairs with the two dots on oxygen atom and two single covalent bonds with each of hydrogen atoms. So when we classify the water, we always think that water should be clear, colorless, odorless, and tasteless. So when we go for the litmus test, it should always have a neutral effect on litmus. It neither turn blue into red or neither turn red into blue, because it is neutral, having a pH 7. Freezing point is that point where the liquid solidify. So almost the freezing point of water is 0 degrees and boiling point is 100 degrees centigrade. And when you go for the structure of water molecule, it is having a exceptional character, which is hydrogen bonding. It shows exceptional extensive hydrogen bonding, because one water molecule is surrounded with four other water molecules. So density, water possesses higher densities, which is 1 gram per centimeter cube at 4 degrees centigrade. And when you compare its value at 0 degrees, it is having a density which is 0.9998. At 4 degrees, it is having a maximum density which is around about 1 degrees, and at 25 degrees you see that it is 0.997. So it is having anomalous behavior at 4 degrees centigrade, and which is showing its maximum density. Earth, and this basically helps to maintain the temperature on Earth. Okay, so water, when it possesses high heat capacity, is very helpful because it helps to maintain the temperature on Earth. Otherwise, the daytime will be too cold, too hot, and the nighttime will be too cold for the human beings to survive on this Earth. The one of the unusual behavior of water is that of the surface tension. Surface tension is basically the amount of energy to increase the surface area by 1 unit area, increase the surface area. And for example, you possess two different type of molecules over here. One is that molecule which is present in the center, and it is experiences the equal and opposite forces from all the sides. But this one molecule which is present at the surface, it experiences only the inward force. So the surface molecule stretch like a rubber, and this is the property through which the water striders helps to walk on the surface of water. And that surface tension is very important because it is having a very unique property, because this unique property helps to for the capillary action. And as you know that we are having a comparison of water and mercury over here, and water is having a heat capacity, which is surface tension, which is about 7.29 into 10 raised to power minus 2, and mercury is having 4.6 into 10 raised to power minus 1 joule per meter square. So having a concave meniscus which is possessing the high adhesive forces and high adhesive forces, because it can adhere to the walls of the container or the test tube, while mercury is having a strong cohesive forces rather than adhesive forces. So surface tension is very important because it helps or responsible for the capillary action. And as you see in most of the examples, that water is basically taken from the roots, and this is because of the capillary action. So this whole phenomena is basically very useful because it is taken the water from the roots to the leaves, and so the water is ascending upward from the xylem cells to the leaves. And you know that this phenomena is also we are basically very familiar with when you having a sponge and put it into the water from one side, the whole sponge get wetted. So this is also due to the capillary action, and that's phenomena is very important for the survival of land plants, because you put water in the roots, but you see that there is a ascending portion, because the water is having that adhesive power, and it adhere with the walls of the xylem cells, and it takes the water from the root to the leaves. So